Alright, it is Sunday night at 9:15. I want to get this video done so I can go to sleep. So let's do this. Here are the corrections for the Chapter 7, Part 1 of the chapter test that you took on Thursday before the long weekend. So for this first problem, what you had to do was solve each of these 6 parts for x using logs when necessary. So I just copied my answer key, took the picture straight onto here. So I'll kind of talk you through each one, but if you want to pause the video if I go too fast for you to make your corrections, that's fine. Feel free to do that at any time. So basically for A, all I did was I took this, I turned it from exponential form into logarithm form using that definition that you guys learned, and then I typed it into my calculator. I don't have a fancy calculator, so in order for me to type it in, I had to do log of 120 divided by log of 5.4, and for letter A I got x equals 2.84. For letter B, I did the same thing. The first thing I did was I changed the exponential equation into log form, and then I went ahead and added 2 to both sides. So right here, I added 2 to both sides, and then again, just typed that straight into my calculator. If I saw mistakes on this problem, it was that people were forgetting to add 2. So just make sure you do that log of 8 divided by log of 5.4 and then add 2. So you get x equals 3.23. Next, this one, I had to turn it into exponential form first before I solved it. So I took this first log equation and I turned it into x cubed equals 12. And then in order to solve this for x, I took the cube root of both sides, so I raised them both to the 1/3 power, and I ended up with x equals 2.29 over here for letter C. For letter D, this was a fraction buster type of problem, so I wanted to get a common denominator on the left-hand side of 6. So I multiplied the first fraction by 3 over 3 to get 6, and then the second fraction by 2 over 2, so that both of those denominators became 6. So distributing in the first one, I ended up with 9 plus 3x over 6 plus 4 over 6 equals 5. And then I went ahead and added straight across the top of my fractions to get 13 plus 3x over 6 equals 5. I then over here multiplied both sides of my equation by 6, so I just had my numerator left. 13 plus 3x was now equal to 30. I subtracted 13 and got 3x equals 17, and then I divided by 3 to get x equals 5 2/3, or 5.67, or 17 over 3. Any of those answers would have been acceptable. For letter E, you have to notice that I gave you 2 equations. They were both equal to f of x, meaning I could do a little substitution action and get this 70 up here. So then I ended up with 70 equals 4 times 5 to the x power. I could then take that, divide both sides by 4 to get 17.5 equals 5 to the x power. And then I turned that into log form and got log base 5 of 17.5 equals x. Punched that in my calculator to get x equals 1.78. That was the answer to E. Last but not least, I took for the last one, I subtracted 2 from both sides, ended up with 4 over x equals 1, and then just multiplied both sides of that equation by x to get x equals 4. So that was a lot of information in those 6 parts. Make sure that you've got all of those correct. Pause the video if you need to, and then let's move on. So here we go. I took this and I screenshotted problems 2 and 3. So we'll go ahead and go through these. So you needed to know those 3 log properties, which were the power, product, and quotient, in order to do these 6 problems. So I started here by taking the log base 3 of 6 plus log base 3 of x, and using that product property to get the right-hand side to be log base 3 of 6x. Knowing that, I now know that x has to equal 10 in order for both of those sides to be equal with each other. Similarly, in letter B, I used the quotient property to make that left-hand side be log of 12 divided by 2. So I took that 12 and that 2 that were in the subtraction and divided them. And that tells me then that 12 divided by 2 give me my x, and I get x equals 6. Okay. Using the next one, I jumped straight into using the product property on the left-hand side to get log of AB, and then the quotient property on the right side to get log of a squared b divided by x. So using that, I know that I want AB to equal a squared b divided by x, and in order to make that happen, I get x equals a. Because if I have x equals a, I get a squared b divided by a, and that squared can cancel out with the a on the bottom to give me just ab. So I get log of ab equals log of ab if x equals a. Alright, I told my class to always look for power properties first if you have them. So the first thing I did in letter D was take this 3 and move it from the front of my log up to be the exponent of that 2. A lot of people in my class told me that 2 to the third power is 6. Remember that 2 to the third power does not mean 2 times 3. It means 2 times 2 times 2. Okay, so 2 to the third power is 8. And given that information, I know that this becomes log base 2 of 2 to the third over 4, which is 8 over 4. Okay, so I get log base 2 of 8 over 4, which is 2. And so I get log base 2 of 2 equals x. Okay, so I'm thinking to myself, if I change this into exponential form, 2 to what power, 2 to the x power, equals 2? Well, if I think about it that way, clearly x must be 1. Okay, 2 to the first power equals 2. Moving on to section problem number 3, you had to simplify these into one log statement using your product properties and power properties and quotient properties. So again, I looked for my power properties first, and I went ahead and moved this 2 from the front here up to be my exponent. Then I took log of 4 plus log of x squared and put those together to be log of 4x squared. And that minus log of y tells me that I should have that divided by y. So my answer for letter A is log of 4x squared divided by y. And moving on to B, again, you do the power property first. We were solving this one for x, so it should have been up in number 2. And so I bring that 3 up to be log of 2 to the third power. Subtract log of 16. That tells me that I should rewrite that as log of 2 to the third power, which is 8 divided by 16. And that gives me log of x. So that says that x has to be 1/2 in order for those to be the same, because 8 over 16 is 1/2. Then you turn the page, and we were doing the solving exponential system. So in number 4, the first thing I did was I took that second equation and I solved it for a. So I get that a equals 3 divided by b squared. Then what I'm going to do is I'm going to take that 3 divided by b squared and I'm going to plug it in for a in the other equation. So I get 12 equals 3 over b squared times b to the 4th power is what that should say, which I think it will in just a second. Yep. So then b to the 4th power over b to the 2nd power, use those exponent rules that we talked about earlier in the year, and you know that b to the 4th over b squared, you subtract 4 minus 2 to get b squared. So I get 12 equals 3b squared. We're going to divide both sides by 3 and then take the square root. So you get that b equals 2. Then in order to solve for a, all you have to do is plug that 2 back in to either one of the equations you started with. So I went ahead and plugged it into the equation over here, this one that I solved for earlier, and I ended up with a equals 3 over 2 squared, which is 3/4. Okay, so those are my 2 answers. And we're going to use a very similar process to do number 5. So the first thing I did is I rewrote both of these equations so that I got rid of that plus 2. Once I do that, then it's basically the same problem I just did. Okay, so what I'm going to do is I'm going to solve one of those for a, and I went ahead and solved that blue equation, that second one for a. So I got a is 28 over b squared, and substituted that in for a in the green equation. So I plugged in that for a. Then I'm going to figure out that b cubed over b squared is just b, and I get 3 equals 28b. Divide both sides by 28, and you get b is 0.107. Now you could have got a couple different answers for a depending on when and how you rounded, So let's see what I got. So I took that 0.107 and plugged it in for b. It really kind of depended which equation you picked to plug that in for. So I went ahead and plugged it into that blue equation I had, and I got a equals 2,439. But as long as you were around there, you got the credit for it. It depended on which of the equations you plugged in. It made your rounding make a bigger difference depending on which equation you plugged it into. But those are the A and B values, somewhere around there you should have gotten. Go ahead and look down at the bottom. We're now going to do this word problem that talks about the flu virus. And the way I set it up was that the initial 8 students that had the virus, I set that up as day 0. And then that meant I had to set up the 3 days later as day 3. Okay, now I know some of you set it up as day 1 and day 4, and that worked just fine, and we'll talk about, kind of what the difference is then. Okay, but assuming you set it up like this, which most of my students did, here's what the picture should look like. It's an exponential growth, based on this equation that they tell you to use. And you have these 2 points. What you do is you want to substitute both of those 2 points into your equation y equals a times b to the x power. So I took both of my xy points and substituted them in, and now it looks just like that problem from up top, except it's even easier. Because if I look at this first equation, I have b to the 0 power. And b to the 0 power is 1. So I already know that a equals 8, just given that equation. So all I have to do now is substitute that 8 in for a in my other equation, which I'm going to do right here. And then divide both sides by 8 and take the cube root of both sides to get that b equals 1.5. So you're going to write the equation using your a and b value, and I got something like y equals 8 times 1.5 to the x power. However, if you did set it up with 1 and 4 instead of 0 and 3, then the a value that you would have gotten for the day before, that 8, would have been 5.33. You should have still gotten the same b value, but you would have gotten an a of 5.33. The process is exactly the same, so it's totally fine if you did it that way, and that's the answer you got. Alright, then part B tells us to predict when half the student body will be infected with the virus. Well, we know that half the student body is 750 students. Okay, so we're going to plug that in for our y. 750 equals 8 times 1.5 to the x power. We divide both sides by 8 when we get 93.75 equals 1.5 to the x power. And then we go ahead and switch that from exponential form into logarithm form. Okay, so now it's in this form, which is what we asked for, your answer in logarithmic form. And then you had to take that and plug it into your calculator as well to give us an answer that's correctly rounded to 3 decimal places. Okay, so if you did it with the green equation, you got 11.199. However, if you did it with 1 and 4, then you should have gotten 12.199. And I know I wrote 12.2, it should have been 12.199. Because it's exactly 1 day later, 1 day more, because you set it up 1 day shifted to the right. But the process is exactly the same. Moving on. Last page. This is the exact same type of problem, except we're talking about exponential decay here with an asymptote at 22. So our k value is going to be 22. But we go ahead and start with our x equals 0 and 100, and x equals 5 and 65. And again, obviously, you could have set this up shifted and got some different answers, but for the most part, this is what I saw, so this is the solution I'm going to give. Alright, so I have my 2 points. I know my asymptote, my k, is going to be at 22, so I go ahead and just plug in those 2 points, just like we did on the last one, with that plus 22 this time. Then I take both of those equations, and again I have b to the 0 power, which is just 1. So you're going to see me use that equation on the left, subtract 22, and figure out that my a is just 78. So from there I can plug in a is 78 into my second equation, which you're going to see me do here. And you get 65 equals 78, b to the 5th power, plus 22. You go ahead and subtract 22 from both sides. Then divide by 78 and take the 5th root, which gives you that b is 0.888. So your multiplier is 0.88, start at 78, and then you have that plus 22, obviously. Your equation should look like this. y equals 78 times 0.88 x plus 22. And that's your equation. Then we're going to use that in parts B and C. So let's go ahead and look ahead. It said use your equation to predict the temperature of the tea after 20 minutes. So we plug in a 20 for x, and then from there it's just simple computing. You should get the answer. Y would be 29.25 degrees Celsius after 20 minutes. And last but not least, we're going to predict when the tea will be body temperature. So we plug in 37 degrees for y, and then we're going to have to use some of our logarithms to solve it for x. So again, there's your equation. We're going to subtract 22, then divide by 78, then turn this thing into logarithm form, and then go ahead and type that into your calculator. So all of this is sort of, you need the same set of skills to do each of these problems, and then it's just adapting it to the problem that's at hand. Okay, so here's what the logarithmic form should look like, and then if you did type that into your calculator, you should have got that x equals 13.893 minutes. And that's the test for you. So go ahead and make those corrections and get ready for the retake that you need to do.